Hello, am I audible? Hello, hello.
Yes.
Okay, thank you. Is my screen visible? Is my screen visible?
Yeah.
Okay, thank you. So, good afternoon, everyone. Welcome to this live session for the NPTEL course Introduction to Machine Learning. My name is Ayan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this live session, I will first discuss some practice problems on this week's contents, like some problems on decision trees, also some problems on parameter estimations and neural networks as well from the last week's content. So first I will discuss some practice problems on these topics, and then I will also try to answer your questions and queries, and if you have any other doubts or questions, you can also ask. So we can start the problem solving session. Another thing to note is that this is a 2-hour long session. So after the first hour, I have to create a new meeting link, and I will share that new meeting link in this meetings chat. And so you have to join the new meeting for the second hour, that is from 4 p.m. to 5 p.m. because Google Meet doesn't allow for meetings for more than 1 hour. So I will notify all of you that 1 hour is done, and I will create a new meeting link, and I will share the meeting link with all of you in the meetings chat. Make sure that you click the link first, or copy the link first, and then leave this meeting, otherwise you will lose this meetings chat. Okay, so this is the first question. This question is on decision trees, which is the topic for this week. So question 1, which of the following properties are characteristic of decision trees? Multiple may be correct answers. So there are 3 options here. First one is low bias, second one is high variance, and third one is lack of smoothness of prediction surfaces. So which of these following 3 are the properties of decision trees? Low bias, high variance, and lack of smoothness of prediction surfaces. You can write your answers in the chat. I hope all of you have already understood the concept of variance and bias and variance. So Akanksha Joshi has written A and B, so low bias and high variance. Asha has also written A and B. So both of you have written A and B here in the chat. So any other answers? Does anyone think C would also be one of the answers? So correct answer here will be all these 3 options, because the third option has not been given by anyone in the chat, but option C would also be one of the properties of decision trees. So low bias, because we have already seen that the way we create the decision trees is very much susceptible to overfitting. So it's a known problem for decision trees that it might overfit the training data. So in that case, overfitting basically means the bias is low. So low bias comes from that point of view for decision trees, and high variance because even a very small change or noise in the training data can drastically change the decision tree, because decision tree is hierarchical in nature. So even a difference in one node, split in one node can change all the splits that will happen beyond that point, that node. That is the subtree rooted at that point So for all the nodes, the splits will change because of one split and at one node. So it is very sensitive to noises. So that's why the variance is also very high for decision trees. So these are the two reasons why it has low variance and low bias and high variance. And third option, that lack of smoothness of prediction surfaces, this is also true, because if you have seen how decision tree actually creates those subtrees, so it basically breaks the feature space. Like if x1 and x2 are the feature space, it breaks down the overall feature space in this rectangular fashion. So these are the different regions that it breaks the feature space into. So there is no smoothness, like you very small change from here to here, you will have a very different output. So very small change will can result in a huge difference in the output. So the smoothness is not present. But whenever you just cross this one of those boundary lines, you get a completely different output. These are the different boundary points. So whenever you cross these different boundary points, you get to a new region and the output is completely different. So this is why the prediction surface lacks smoothness. But in case of logistic regression or in case of neural networks, we try to estimate the weight values or coefficient values, and because of that the prediction values have a smoothness to it, but that is not true for decision trees. So all these three options are correct in this case for decision trees: low bias, high variance, and lack of smoothness of prediction surfaces. Is there any doubt in this question? So A, B, C, all three options will be correct here. This is the second question. So a small data set is presented here, and you have to find out the initial entropy for this decision. This is the decision variable, or Y we can say, malignant. This is the decision variable, and the input features are age, vaccination, tumor size, and tumor site. So these are the four inputs features, and the Y or the decision variable is malignant. So you have to find out the initial entropy of malignant. So how can we compute that? So there are two distinct values of this Y variable malignant, 0 or 1. So these are the two different output classes, you can say. So how do we compute this entropy? So the formula for computing the entropy looks like this: E of let's say y is the decision variable. So we try to compute it like this. So summation of PC log base to PC, where PC is the probability for class C. Probability for class C. So there are two classes in this data set, 0 and 1. So there will be P0 and P1. So now what should be the value? We have to compute the PC values first for every class, and then we have to apply this formula to find out this overall entropy. So there are two classes, 0 and 1. So P0, what should be P0? There are two classes, 0 and 1. So P0 and P1, these are the two values that we have to find first. So P0, what is P0 here? So how many zeros are there in this malignant class? How many zeros are there? 1, 2, 3, 4, 5, 6, 7. Those 7 points are zeros, and 1, 2, 3, 4, 5 ones. So there are 12 data points in total. Out of the 12 data points, these 7 points are zeros. So probability of 0 is 7 by 12. Similarly, probability of 1 will be 5 by 12 because there are 5 ones. So P0 and P1, they are the two probabilities of the two classes, 0 and 1. And now we have to apply this formula. So it would be P0 log base 2 P0 plus P1 log base 2 P1 minus of this whole thing. So this is the expression that you have to find out. So you will actually need a calculator for this. So overall this is the formula that you have to use. P0 log base 2 P0 plus P1 log base 2 P1, where P0 is the probability for class 0 and P1 is the probability for class 1, and then you have to find out this expression. So the correct answer would be, if you compute this whole thing, so this is the B would be the correct answer, B which is 0.9798. So minus 5 by 12 log base to 5 by 12, this is coming for the class 1, and for class 0 this part is coming 7 by 12 log base to 7 by 12. Akanksha has asked why log base 2. So the whole operation is done in log base 2. Base 2 because in decision trees we generally split the data into two halves, two splits. We do multi-split also, we do, that is a different issue, but generally we prefer base 2 in this case. And even if you take any other bases, the entropy value would be different, but the main purpose of computing these entropy values and everything is to find out the information gain at for every variable and find out which has the highest information gain. So whatever base you take, it would not really matter whether you take 2 or e or whatever, or even 10. Information gain of the variable for the if you take base 2, the information gain of a variable would be highest in that. Even if you take it base 10, the information gain would be highest for that variable only. So the variable would not really change even if you change the base. So that's why, but if you try to compute only the entropy, you have to use base 2 because this is how we compute it. So it comes from information theory background. So it's not possible to answer why exactly we take this 2, but this is a formula for entropy, so you have to take it. And whether you take 2, 10 or even e, which is natural log, the information gain would be highest for the same variable, so it would not change. So this is how you compute entropy. Is there any doubt in this, how we are computing this? Does anyone have any doubt in this question? Okay. Now the question 3, for the same data set for which we just calculated the entropy, the same data set is given here, and now you have to find out the information gain for the variable vaccination. So this is the variable vaccination. In the previous question we found out the entropy for this malignant, which is the decision variable here. Now you have to find out if we want to split with respect to the variable vaccination, so we have to find out the information gain first for this variable. So what will be the information gain for this variable vaccination? So how do we compute this information again for a given variable? So can anyone tell me how we compute this information gain? For information gain, first we need the entropy for the decision variable that we have already computed in the last question, and also we need to compute something else. Does anyone know how to compute this? So for information gain, so if the vaccination is the variable for which we want to find out the information gain, so this is the vaccination variable. So vaccination variable has two distinct values, 1 or 0. So these are the two distinct values that it can take, 1 or 0, that we can already see from this dataset. So only 1 and 0 values are here in this dataset, in this column. So it can take 1, it can take 0. So this is how we split with respect to one variable. Vaccination can take 1, so it goes this way. Vaccination can take 0, in that case it goes to this way. So first we need to find out how many elements have what is the fraction of points that are going in the direction of 1, and what is the fraction of points that are going in direction of 0. So in the for 1, how many elements are there? 1, 2, 3, 4, 5. So there are 5 ones out of 12. So 5 by 12. So this is the probability of going towards this the left hand side. And how many zeros are there? 1, 2, 3, 4, 5, 6, 7. So 7 zeros are there. So probability is 7 by 0. So probability of 0 is not this one. Yes, 5 by 12 and 7 by 12. These are the two splits. Now we have to find out the entropy of this split and also entropy of this split. So you have to find out the entropy values in two different splits. These two parts, and then we have to combine these two. So for this left hand side, you have to again find out how many So for finding out entropy of this side, you have to again use the decision variable. How many which are the elements that have gone to this left hand side, and how many are going to right hand side, and based on that you have to find out what is the entropy of this side and what is the entropy of this side, and then you have to combine, and the overall information gain formula is, information gain for vaccination would be the entropy of the whole data set. So whole data set is sometimes written as E of S. S is the whole data set, plus minus summation of so it would be like this, minus, so 5 by 12, this is the 5 by 12 is the fraction of elements that are going in the left hand side. So 5 by 12 into entropy of this side. So the entropy of, let's call it right hand side, R, and this side is L. R minus 7 by 12 into E of, this one is L and this one is R, L and this one is R. So this is the overall formula. The ES we have already found out in the last slide. This is the ES. ES is the S is the whole data set. So what that is the entropy of the whole data set. And then we have to find out this EL ER, which is the entropy of the left hand side and entropy of the right hand side. So that you can find out using the same formula in the last slide, entropy formula, which is this one is the entropy formula. So using this you have to find out this EL and ER, and then you can find out this whole information again with respect to vaccination. So if you put all the probability values into it, so this is the total entropy of the data, entropy of the total data set, E of S, and then this part is the entropy of the left hand side. Yes, entropy of the left hand side. This is the entropy of the right hand side, and this is the probability of going towards the left hand side, and this is the probability of going towards the right hand side. That is, this is the probability, the probability, this is the fraction of elements that are going to left hand side, and this is the fraction of points that are going that will be 0. So 7 by 12. So then these are the two weights, and you have to find out using this formula. So has anybody understood this? This might look a little complicated if you have not studied the video lectures. If you have not gone through the lectures, then the formula might look very complicated. Is it okay, or should I explain it again? If you have any doubts, you can ask me later. This is the fourth question. So there are two statements given for decision trees. Statement 1 is decision trees are linear non-parametric models. Statement 2 is a decision tree may be used to explain the complex function learned by a neural network. So which of these statements are correct? Whether statement 1 is correct, or whether statement 2 is correct, or both are correct. Decision trees are linear non-parametric models. This is the statement 1, and statement 2 is a decision tree may be used to explain the complex function learned by a neural network. So Akanksha has written statement 2 is correct, and what about statement 1? Is 1 correct or not? Akanksha has written it is not parametric, non-parametric, but also non-linear. So 1 is not correct. Yes, so statement 1 is certainly not correct. It is not linear for sure, and also non-parametric. It is also non-parametric. So non-parametric part is correct, but it is not linear. So statement 1 is not correct. In statement 2, a decision tree may be used to explain the complex function learned by a neural network. This is true. This is right. Decision tree can actually be used to interpret the output of a neural network. So this is it has a very high interpretability, decision trees, which neural networks and even logistic regressions lack. But interpretability is very high, and it can actually be used to interpret how the neural network is giving some output. So it is actually used for that. So statement 2 is correct. So statement 1 is false, but 2 is correct. So C option would be the right answer. So Akanksha was right. Statement 1 is false and statement 2 is true. So option C is the correct answer. Fifth question. Which of the following machine learning models can solve the XOR problem without any transformation on the input space? So there are 4 options: linear perceptron, neural networks, decision trees, and logistic regression. Which of the following machine learning models can solve the XOR problem without transforming the neural network input space? And multiple answers might be correct here. Akanksha has written C, which is decision tree. Any other answers? Akanksha has written B also. So B and C, neural networks and decision trees. Yeah. Anyone else? Any other correct answers here? So XOR problem, I hope all of you understand what is the XOR problem. So in XOR problem, so if these are the two inputs x1, x2 and y is the output, so in XOR, so when the two inputs are equal, then we get zeros, and when the two inputs are different, then we get 1. So this is the output for XOR. So if we plot it, so if this is x1 and this is x2, so we get a 0 point here. This is 1, this is 1, so we get a 0 point here, we get 1 1 here and 1 1 here. So let's call these plus values, it makes it easier. So these points are not linearly separable, as you can see. These are the two 0 points and these are the two plus points. So you cannot separate these two sets of points using linear separators. You cannot certainly separate these. So you have to create something like this, you have to create like a separator like this, or you might also create something like this. This can also separate, but linear separators are not possible for this. And if we see these four options, the first one, linear perceptron, it's a linear separator, you cannot use that. And neural network can be used for separating non-linearly separable data points as well, using hidden layers and hidden units, and also activation functions. You can use all these things to have non-linear decision boundary points. So linear neural networks is one of the answers. It can solve this problem. And decision trees, obviously decision tree simply breaks the input space down into several parts. It would simply create decision boundaries like this. So it creates such rectangles in the input space, and that way you can separate these two sets of points using decision tree as well. Decision tree is also non-linear non-linear model, so you can use decision tree as well. And logistic regression is a linear model, so you cannot use logistic regression here. So these are the two correct answers, neural networks and decision trees. Vaikendrajit has written B, neural network. So neural network is right answer, but decision tree is also one of the answers. So there are two correct answers, neural networks and decision trees. Because neural network certainly can be used if by introducing hidden layers and activation functions, we can make it non-linear in nature. So obviously it can be done. And also using decision tree is also non-linear model. So decision tree can also be used for this. So these are the two correct answers, B and C. So by XOR problem, we were trying to mean that any kind of non-linear problem. XOR is a non-linear problem because the points are not linearly separable. So the neural networks and decision trees, these are the two non-linear models. So that's why for any non-linear problem, these two would be the answers. Is this now question 6? Which of the following is or are major advantages of decision trees over the other supervised learning techniques? Note that more than one choices may be correct. So which of the following is or are major advantages of decision trees over other supervised learning methods? Option A is theoretical guarantee of performance. Option B is higher performance. Option C is interpretability of classifier. Option D is more powerful in its ability to represent complex functions. So which of these following options should be correct here? Advantages of decision tree. You can write your answers in the chat. Akanksha has written A and C. A is theoretical guarantees of performance, C is interpretability of classifier. Any other answers? So here interpretability of classifier is the only correct answer. A, theoretical guarantees of performance, this is not correct completely, because neural network decision trees suffer from the problem of overfitting. So overfitting happens very frequently in case of decision trees. The training error becomes very low, though the test error might not be that low, it might be very high. So we don't have that guarantee of performance, theoretical guarantee of performance. So generalizability is not very high in case of decision tree, so it would not be correct. Higher performance, again the same reason, it can suffer from overfitting, and it is also very sensitive to noises or outliers. That is why it has very high variance. Interpretability of the classifier, this is the only correct answer, because we already discussed that it can also be used to interpret the outputs for neural networks, logistic regression, even linear regression for these models. So interpretability is very high. You can literally see how different different values of different variables influence the output. So that is why interpretability is a major advantage for decision trees. And option D, more powerful in its ability to represent complex functions, that is not right. Neural networks can model any complex function given very deep neural networks or more number of nodes. It can also mimic any complex functions, so it is much more powerful than decision trees in that regard. So option D is not right. So C is the correct answer. C is the only correct answer. Interpretability of classifier. C is the right answer. A will not be right answer because of overfitting and high variance. These problems, you cannot guarantee the performance of a decision tree. Question 7. Consider a dataset with only one attribute, categorical attribute, and suppose there are q unordered values in this attribute. So you have one categorical attribute, and there are q different values that the attribute can take, categorical values. How many possible combinations are needed to find the best split point for building the decision tree classifier? Note that it only makes binary splits, so the two branches could be present at max, not more than two branches can be present in any split. So how many possible combinations are needed to find the best split point? So basically there are 1 2 3 like this. There are q objects or q numbers have been given to you, and you have to split this whole set of q numbers into two sets or two groups. Let's call it s1 and s2. So you have to split it into two groups. Now how many ways you can do that? So this is the question actually. Q objects are given, q distinct objects are given, and you have to form two groups by splitting those objects. How many ways you can do that? So this is a combinatorics problem. So I hope the question is clear using this simplification of this problem. You are given q unordered values 1 2 3 to q, and you have to split this set into two sets, s1 and s2. How many ways you can split it? So for every value, so 1 2 3 up to q, so this is the set. For every value you have two choices, isn't it? Either it goes to set 1 or goes to set 2. So there are two choices for every value, for every number. 1 can go to s1 or s2, 2 can also go to s1 and s2, 3 can go to s1 and s2, q can also go to s1 and or s2. So there are two choices for every number. There are q numbers, so 2 to the power q is the number of ways you can create two sets by splitting the whole set, 2 to the power q. And now from that there are two trivial cases where this s1 is completely empty and all the elements go to s2. That can happen, or the other way around, that is s2 is s1 is completely full, that is all the elements go to s1 and s2 is completely empty. So these are the two trivial cases that we have to remove. So minus 2 to the power q, minus 2, these are the two cases that we don't want, because those two cases are not really splits, they are the same as the original set. So those are the two trivial cases that we have to remove. Now if we consider 1 2 3 4, these are the four numbers, and we create two splits like this, 1 2 and 3 and 4. So this is set 1 and this is set 2. So for every such splitting we will get another split where 3 and 4 are present in s1 and 1 and 2 are present in s2, basically the reflection of s1 and s2. So that's why we have to divide this whole thing by 2. Divide this 2 to the power q minus 2 by 2, because for every splitting that we have a completely reverse splitting also in that number. So that's why 2 to the power q minus 2 divided by 2. So this will give me 2 to the power q minus 1 minus 1. So this is the answer. which is option D. So is it understandable? How do we get to this number, 2 to the power q minus 1 minus 1? Okay, so this is how you have to compute. So this is a combinatorics related problem, not though it comes from decision trees, but it doesn't have you don't have to have any knowledge of decision tree at all. This is based on combinatorics mostly. So D, option D would be the correct answer. So first hour is done. This meeting link could expire, so I have to create a new meeting link again, otherwise this meeting would be over. So I'm creating a new meeting link and I'm sharing it in the meetings chat. So I have already shared the new meeting link in the chat. So everyone please go to this new meeting and I will wait for a few minutes in this meeting so that all of you go to this new meeting. Then I will end this meeting and join the new one. So everyone please join the new meeting link. Is my screen visible? Hello, am I audible? Can you confirm? Is my screen visible? Okay, thank you. So seventh question is done. Now I move on to question 8. So this is the question 8. This is on neural networks. So the neural network given below takes two binary valued inputs, x1, x2 belonging to 0 and 1, and the activation function is the binary threshold function. So hx is 1 if x is 0, x is greater than 0, 0 otherwise. Which of the following logical functions does it compute? So 4 options: OR, AND, NAND, and none of these. So this is the neural network. X1 and x2, these are the two input features. There is one bias term plus 1, plus 8 and minus 2. These are the three coefficients or weight values and hx is calculated as a binary threshold function, that is hx is 1 if x is greater than 0 and hx is 0 if x is less than equals 0. So which of these four functions does it compute? Asha has written option B, which is AND. Any other answers? So how do we do that? So we have to find out the truth table. So hx, so basically hx is 1 if so what is the linear function that it computes using these coefficient values? So this computes 8x1 plus 8x2 minus 12. So this is the linear function. So if this value is greater than 0, so if this value is greater than 0, then output is 1. So 1 if 8x1 plus 8x2 minus 12 is greater than 0, and 0 otherwise or else. So this is the thing that it computes. The hx is 1 if 8x plus 8x2 plus minus 12 is greater than 0, and 0 otherwise. So now if you compute the truth table using this x1, x2 and hx is the output. So 0 0 1 1 0 1 0 1. So when x1 and x2 both are 0, then this value of this linear function is minus 12, because x1 and x2 values are 0. So minus 12, so that means hx would be 0, because this is this comes under this condition, else condition. So this should be 0. If x1 is 0 and x2 is 1, so in that case it is minus 4. This 8x1 plus 8x2 minus 12, it would be minus 4. So it's still negative, so output would be 0. Now x1 is 1 and x2 is 0. Again the same, minus 4. The linear function would compute minus 4, which is still negative, so it's still 0. And finally, if both the inputs x1 and x2 are 1, in that case it would be 8 plus 8 minus 12. If x1 and x2 are both 1, then 8 plus 8 minus 12, which is 16 minus 12, so it's 4. So 4, that means it is positive, it comes under this condition, so it would be 1. So this is the truth table that it would compute. And so if you observe this truth table, you will find out that the output hx is 1 only when both x1 and x2 are 1. So which is and for every other case it is 0. So this is surely AND gate. So in AND gate, if the output is 1 only when both the inputs are 1, and in all other cases it is 0. So this is what we can observe from this table also, that when x1 is 1 and x2 is also 1, then only hx is 1, otherwise it's 0. So it is x1 and x2, so it is computing x1 and x2. So the B would be right answer. So Asha has written the right answer here in the chat. So B and would be the correct answer. So this is how you can compute. So this is for and such neural networks can be created for every other gate, like OR, NAND, NOR, XOR. For every gate you can compute. For XOR it is not possible, because XOR requires non-linearity, which is not possible using such neural networks where there are no hidden layers. For other gates like AND or not, for such gates you can create such neural networks. So this is example of AND. So AND would be the right answer. So this is the question 9. This is on decision tree. Decision trees can be used for the problems where there are 4 options, in which problems it can be used. Attributes are categorical, attributes are numeric valued, attributes are discrete valued, in all the above cases. So in which of these cases decision trees can be used? Akanksha has written all, which is option D in all above cases. Any other answers? So here the answer would be D. The answer would be D, because decision trees can be used for any kinds of attributes, whether it's categorical, numeric, discrete. In all cases decision trees can be used. So option D would be right answer. If it is categorical, it is very straightforward. You create multi-way splits. If there are only 2 categories for the attribute, then binary split is the choice, and if we have multiple different categorical values for the attribute, you will go for multi-way splits, which is similar to binary split. And if you have numerical values, then that is if you have continuous values, then you have to discretize the value and then go for the multi-way splits, or you can also find out the splitting point, and based on that you split it in this way, that greater than this way, and if it is less than this, it goes to this way. So that way you can do. And for discrete values, it is again using binary or multi-way splits you can do it. So all for all 3 cases decision trees can be used. So D is the right answer. D in all above cases, this is the right answer. Question 10. This is again on decision tree. In a binary classification problem, out of 30 data points, 12 belong to class 1 and 18 belong to class 2. So what is the entropy of the entire data set? So you are given 30 data points, and 12 of which belongs to class 1 and 18 others belong to class 2. So what is the entropy of the data set? So there are 2 classes, class 1 and class 2. So how do you compute the entropy of the data set? We have already done a very similar question earlier in this session. how you compute the entropy of a dataset for different classes. So can you write in the chat how we compute, what is the formula for this? Akanksha has written sum the product of probability of each class with the log of its probability. So you have to find out for the two classes. So there are two classes, let's say P1 and P2 are the probability values for the two classes. So what will be P1 in this case? So there are 30 data points and 12 belong to class 1. So P1 is the probability for the class 1. So there are 30 data points in the class 1 and 12 data points in class 1, and there are total 30 data points. So 12 by 30. Similarly we compute P2, which will be so 18 belong to class 2, so 18 by 30. So these are the two probability values, and now the entropy formula is given by minus of P1 log base 2 P1 plus P2 log base 2 P2. So we have already computed P1 and P2, so you have to just plug these two values in. 12 by 30 log base 2 12 by 30 plus 18 by 30 log base 2 18 by 30. So this is the way you have to find this entropy, and once you find out this entropy, you will get option A, which is 0.97. So this is the formula for the entropy. There are two classes, plus and minus. In that case, entropy would be minus P plus log P plus minus P minus log P minus. So in this case, P plus is 12 by 30 and P minus is 18 by 30. So given a data set, you have to find out the probability values for different classes, and then you have to use this formula to find out the entropy of the entire data set. And in this case, if you compute these values, it would be 0.97 A. Question 11. So this is on parameter estimation. So given n samples x1 x2 up to xn drawn independently from a Gaussian distribution with variance sigma square. So this is actually sigma square, not sigma subscript 2, it is sigma square, and unknown mean mu. So this variance is known, we consider this variance to be known, but the mean is unknown, mu. So find the MLE of the mean, or the maximum likelihood estimation of the mean. So which of these values would be the correct MLE for the mean mu? So how do we compute MLE in for any set of samples? How do we compute MLE? So x1, x2, xn, these are drawn from a single Gaussian distribution. From the same Gaussian distribution, we draw these samples x1, x2, xn, and now we are trying to find out the mean of that Gaussian distribution using maximum likelihood estimation. So, and has anyone of you computed this? So the method that we have to follow for finding this MLE for mu is that, so x1, x2, xn, all the points are drawn from same probability distribution. So for probability for every point px1 is let's call it pxi. So pxi is these are drawn from Gaussian distribution, so we already know how Gaussian distribution would look: e to the power minus xi minus mu whole square by 2 sigma square. So this is the Gaussian distribution. So so this is for pxi given mu, parameterized by mu. Now for MLE, we have to multiply this probability value for every point. This is the likelihood for one point. Now the likelihood for all these samples p x1, x2, xn for mu is product of p x1 given mu I equals 1 to n, and then we have to take log of this. Sorry, let me write it differently. So actual log likelihood will be log of p of x1, x2, xn given mu I equals 1 to n. So it would become summation. The log the product under log would become summation. So log of pxi given mu I equals 1 to n, and so the log is applied to this exponential. So what we will finally get is that the L would be some constant plus summation of xi minus mu whole square by 2 sigma square for I equals 1 to n. So this is the log likelihood expression that you will get. Now what you have to do is that you have to we are trying to estimate mu. So we have to take the derivative of this log likelihood with respect to mu and set it to 0. So then the L is k plus summation I equals 1 to n xi minus mu whole square by 2 sigma square. This is the expression. You have to take the derivative of L with respect to mu. So if you compute it, so yeah, this is the log likelihood that you will get. K is a constant, so you don't have to worry about that. It will be derivative of this with respect to mu will be 0. So del L del mu would be derivative of k with respect to mu is 0, and then derivative of this part with respect to mu will be summation xi minus mu, negative will come out, 2 sigma square I equals 1 to n. and this is 0. So from there we can write minus is not required, x minus mu equals 0, I equals 1 to n. So summation xi I equals 1 to n minus, so if we take this mu out of this summation, it will be n into mu equals 0. So now mu will be summation xi divided by n, I equals 1 to n. So this is, so mu is basically the mean of all the data points that we have sampled. So the C option is this one, summation over xi over I equals 1 to n divided by n. So it's also pretty straightforward to understand why this mu is coming for MLE. We are independently sampling these points x1, x2, xn, and to find out the mean of the Gaussian distribution from which we have sampled it, the mean is simply the mean of all the points that we have sampled. So this is the mean. So this is the overall process, how you can compute the MLE for the mean or for any parameter of the distribution. Similarly, if this variance is unknown, you can also find out the MLE estimate for the variance sigma square as well in the similar way, that you have to find out the log likelihood which we have computed here, and then you have to find the derivative of log likelihood with respect to the variance, and then you can estimate the variance as well, MLE estimate of the variance. So this is how you do it. Option C would be the right answer. So yes, so these were the problems that I wanted to discuss today. This was the last problem. So the problem solving part is done. Now if you have any questions or queries, you can ask, or if you have any other doubts in these questions that I discussed today, you can also ask about that. Does anyone of you have any other doubts or questions? Akanksha, we don't handle how exams are done. Will it be completely MCQ type, or we are live session TS, so we don't have much idea about what are the different types of questions that will be asked. So there are normal regular NPTEL TS who handle all these cases, or the instructor who handles the assignment assignments and also the exams. So they would be able to tell. We have no idea about what kinds of questions are asked in the exam. So you can ask in the discussion forum. So normal TAs and the instructor would be able to answer this question about your queries about the exam. So we don't know much about that. Is there any other questions or doubts? So if there are no more questions or doubts, we can end this meeting. Thank you everyone. You may leave this meeting now if there are no other questions or doubts. Thank you everyone. I'm ending this meeting now.